In this video, we'll learn about truthy and falsy values in JavaScript. In the previous video, we saw that logical operators can work with non-Boolean values. Now we'll understand how JavaScript decides whether any value is true-ish or false-ish. This is a fundamental concept that you'll encounter everywhere in JavaScript code. So, JavaScript doesn't require Boolean values in conditions. Any value can be evaluated in a Boolean context. Let's start with a simple example. So here, to be or not to be. We saw this in a previous video. The string to be is evaluated as true, so the or operator returns it. But how does JavaScript decide that it's going to evaluate to be true? Well, it turns out there are 6 falsy values, and everything else is going to be evaluated as truthy. So first, let's reiterate these terms that I'm using: truthy and falsy. Right? Truthy are values that evaluate to true in Boolean context. Falsy are values that evaluate to false in Boolean context. There's 6 values. There's 6 falsy values. False, obviously, 0, the number 0, empty, a string, whether you use single or double quotation, null, undefined, and not a number. Everything else is truthy. So let's take a look at evaluating all of these 6 cases. So here I'm using the Boolean constructor and pass the value as an argument to it, and this will construct a Boolean. This Boolean with the capital B is a wrapper class for the Boolean primitive type. Now in the previous video I showed you how you can use the double not operator. Both of them will doing the same thing. Using the Boolean, the wrapper class, is considered a safer, better, more modern approach to this. Anyways, all of these will be evaluated as false. So for the sake of showing you an example, let's see some common truthy values as well. Well, any number that's not a 0, any string that's not empty, any object, including empty objects, and any array, including empty array. And basically, well, even functions, because, well, technically functions are objects, but we'll talk about that in a future video. So let's take a look at some examples of this. I think the confusing part, or perhaps the surprising part, is how empty string is evaluated as falsy, but empty object, empty array are evaluated as truthy. So just keep that in mind. Now, in the previous video, I talked about how these interesting ways that JavaScript evaluate Boolean operators lead to some common patterns that people treat these as features of the language, and they incorporate them into their code and end up coming up with idiomatic patterns that many JavaScript developers use. So let's take a look at some of those patterns again. Let's look for example, the first one, checking whether a value exists or not. So here's an example of it. User is supposed to be an object. If user exists, then go ahead and do something about it. If it doesn't exist, then deal with it, maybe throw an exception. So very common thing to do in JavaScript code. Technically is just shorthand for this, right? So you're basically saying if user is not undefined and user is not null, then you're saying user exists. And I actually prefer the longer version of it because it is self-documenting and it clearly signals the intent. But people, well, JavaScript developers, somebody might look at this code and suggest or even recommend to you to change it to this. Anyways, let me show you another example that we've seen in a previous video, and then I want to use that as an opportunity to talk about some other alternatives. So for example, here's an example of using Boolean expression in a way of defining default parameters. So I have calc wage, and then it takes 2 arguments, hours work and hourly pay rate. And if you don't provide the second argument, it will set it to some reasonable default value. So this works, and I've shown you a different example, but with the same concept in a previous video. So a modern alternative to this is to use default parameters for functions. Now, we haven't officially covered functions. It will be a future lecture, but I want to just show you how that works and use that as an argument to show you perhaps like the pros or cons of relying on these sort of idiomatic older style of writing code or using alternative modern ways of writing the same code. So what you can do, for example, here is to take this default value and put it up here. So this is a more recent addition to JavaScript that allows you to define default values for parameters. So you can take this line out now, and it behaves exactly the same, right? So that's an interesting behavior, but you got to be careful with doing things like this. So I want to show you another example that perhaps shows some of the limitations of it. So let's say I have a function called safe divide, and you don't want to divide a number by a zero denominator. So what you do is, let's say you give it a default value, right? And you're thinking, all right, okay, if somebody didn't provide me the denominator, I'll just set it to 1. And that works in like most logical cases. Like if I give you 10 and I give you 2 as the denominator, then you return 5. If I just give you 10, then you just set it by default to 1. But what happens if I actually give you 0? Or I give you a variable that ends up being evaluated as not a number? In these cases, this operation is gonna break down. So you get 5 and 10 in the first two cases, but in the other cases you get like infinity and not a number. So in a case like this, it's perhaps better to use the older style of writing code like this and take this out, because when you write this line, you're not just providing a default value, you're also guarding against a number of other cases. So in the default value, you're just saying if denominator is undefined, so that is like here, it was not provided, replace its value with 1. But what you're doing here is that if denominator is undefined, it would be falsy, so you would return 1. But also, if denominator is null, it will return 1. Also, if denominator is not a number, it will return 1. Also, if denominator is 0, it will return 1. So if you take this value out and use this pattern, then you run it, and you basically have a safer divide in all of these cases now. So this is an example that like using the older idiomatic way of like guarding or defining a default value does more than just defining a default value. Now for completeness, I'm gonna show you a case that is sort of a counter example to just what I showed you here. So let's take a look at this example. Counter. You would write counter or 10, right? And so you're saying that if counter was like undefined or null or not a number, so you're kind of guarding against all of those cases. However, what happens if you actually really want to set counter to 0? 0 is still falsy. So if you want to actually set counter to 0, it will end up being set to 10. So there's a trade-off, right? There's a trade-off. You got to be careful with these behaviors. You can't just prescribe that, hey, do this is always better, or use default parameters. Default parameters is always better. This is why we're spending time and going over the nuances, because those nuances matter. They create edge cases. All right. So to wrap things up for this video, what we covered was truthy and falsy values in JavaScript. The good news is there are only 6 falsy values. The false itself, 0, empty string, null, undefined, and not a number. Everything else is truthy. So the key insight is knowing when to use each pattern. For example, you use default parameters when you only want to catch undefined parameters. Use the OR pattern when you want to catch all falsy values. Be careful when there are some exception to it, like the counter example that I showed you.